Welcome back to The Explainer. Today, we're diving into an incredibly chilling forensic mystery, the crash of Air India Flight 171. We are going to look closely at a tragedy that absolutely should not have happened. We'll be examining the raw data, the reconstructed flight path, and a glaring discrepancy in the official timeline that investigators are, quite frankly, still struggling to answer.
Why did you turn it off? I didn't do it. Just imagine hearing that. That haunting exchange, captured in the cockpit of a Boeing 787 just seconds after takeoff, really sets the stage for today's investigation. You've got two highly trained pilots facing an impossible situation. And to understand what really went wrong here, we have to look past the wreckage and dig straight into the cold, hard data.
Section 1. The doomed flight. All right, let's dive right into this by establishing the baseline of exactly what happened on June 12, 2025 in Ahmedabad. Understanding the starting conditions is totally critical for everything that follows.
What's really interesting here is that we're looking at a completely normal, capable setup. You have a heavy aircraft, we're talking over 200 tons, with 54,000 kilos of fuel loaded up for a 9-hour flight to London. It was a hot day, about 36 degrees Celsius, meaning the air was pretty thin. That naturally requires more runway and more speed to generate lift, but honestly, this was well within the Boeing 787's capabilities. Crucially, look at this crew. Captain Sabharwal had over 15,600 flight hours. First Officer Kundar had deep aviation roots and thousands of hours himself. We are talking about a highly experienced crew flying a route they knew like the back of their hands.
Section 2. Reconstructing the crash. Let's move to the actual sequence of events and see how the timeline of the disaster unfolded. By stabilizing and matching up the available CCTV footage frame by frame, experts were actually able to build a full 1-to-1 scale 3D reconstruction of the flight's final moments over the city.
And this reconstruction brilliantly illustrates how rapidly a textbook takeoff escalated into an absolute disaster. Everything is perfectly normal up through V1 and VR. The plane transitions into the air. But shortly after clearing the airport perimeter wall, the aircraft starts losing altitude and deviates to the left, striking trees and a chimney. What is incredible, though, is the post-impact data. Even as the aircraft was literally falling apart and hurtling forward at 150 knots, the fuselage maintained an 8-degree nose-up attitude. Those pilots were pulling back on the control column until the very bitter end, fighting with everything they had to clear those buildings.
But, physics won. Following the initial impacts that tore away the landing gear, the tail, and the wings, the massive, fully fueled aircraft struck a series of student dormitories. From the moment of that major impact, it exploded into mere fragments within just 2.5 seconds. It was devastatingly fast. There was simply no time.
Now, a lot of people have been asking why the plane crashed with its wheels still down. Well, the landing gear never retracted because the first engine began to spool down when the plane was a mere 55 feet off the ground. Standard procedure dictates that a pilot absolutely must verify a positive rate of climb, basically ensuring the plane is safely gaining altitude before calling for the gear up. At 55 feet, amidst an instant, terrifying crisis, they simply never had the time or the altitude to make that call.
Section 3. The timeline discrepancy. Getting to the real core of the mystery here, a glaring anomaly was discovered when they compared the official preliminary report's timeline to that stabilized 3D simulation data.
Okay, so check this out. The official report states the plane hit its maximum speed of 180 knots, and then, immediately after, the fuel cutoff switches were moved, shutting down the engines. But the frame-by-frame simulation? It shows something entirely different. It shows the aircraft continuing to accelerate for 5 full seconds after the engines were supposedly shut off, reaching 196 knots, all while still gaining altitude.
This is the massive, unresolved puzzle we're looking at today. Inside a jet engine, when you cut the fuel, thrust collapses almost instantly. Any remaining high-pressure gases flush out in under a second. There is no such thing as 5 seconds of residual takeoff thrust. None. So, what could possibly create a 5-second rise in speed after those switches were flipped? The experts are still trying to decipher this bizarre contradiction.
Section 4. Evaluating the 4 theories. Setting that physics anomaly aside for just a moment, let's systematically evaluate the 4 working theories behind the fatal engine shutdown. And we're going to work backward to eliminate them, based strictly on the mechanical evidence.
Basically, these are our 4 possibilities. And by looking at the actual wiring and mechanical design of the Boeing 787, we can test each one of these to see what holds water. Let's start at the bottom.
Theory 4 suggests the engines just failed on their own and the switches were never touched. Well, actually scratch that.
The 787 has a dedicated data line that checks and records the direct physical position of those cockpit switches every single second. That's the sampling frequency. The black box definitively recorded the switches moving to the cutoff position. Because this is a physical, mechanical reading, there are no software tricks here. The switches absolutely moved. Theory 4 is completely eliminated.
So what about Theory 3? Could the plane's own software have gone rogue and done it? The 787 has the system called TCMA, which is designed to cut fuel if an engine's power exceeds safe limits. But here's the catch. TCMA doesn't physically move the cockpit switches. Instead, it closes a high-pressure valve deep inside the engine itself. Furthermore, once TCMA activates, it requires ground maintenance crews to reset it. It literally cannot be reversed midair. Yet, flight data shows the switches move back to run, and the engines actually restarted 14 seconds later, so TCMA definitely wasn't the cause. Theory 3 is out.
All right, let's move to Theory 2, accidental activation. Could a pilot have just bumped them? Well, think about the physical safeguards for a second. To move these switches, you actually have to pinch them, pull them upward against really heavy spring pressure, and bypass both raised physical guards and mechanical base stops. An accidental bump might, in some freak 1 in a million scenario, move one switch, but accidentally triggering both switches through all those heavy safeguards within a 1-second gap of each other, that is mechanically and statistically almost impossible.
Which brings us to the crucial point. By pure process of elimination, manual, intentional activation is the only theory that the mechanical evidence cannot refute. Someone in that cockpit intentionally pinched, lifted, and pulled those switches to cut off just seconds into the flight. And remember that haunting voice transcript? Why did you turn it off? I didn't do it? Yeah.
Section 5. Unanswered investigation questions. Because, as you'll see, beyond the mechanical mysteries inside the cockpit, the aftermath of this crash revealed some deeply concerning systemic issues. The investigation itself faced severe operational hurdles right from day one.
And this brings us to a rather shocking reality check. To extract data from the damaged forward black box, investigators needed a specific piece of equipment called a golden chassis. Now, despite Air India alone operating over 30 Boeing 787s, the country's own Aircraft Accident Investigation Bureau did not possess this essential tool. They didn't even have the cables for it. They actually had to wait to import it all the way from the US. It is deeply concerning that a local bureau lacked the baseline capability to extract data from one of their most common commercial aircraft.
But the failure of equipment on the ground is matched by a terrifying failure of equipment on the plane itself. The rear flight recorder, placed in the tail specifically to survive impacts, suffered such extreme thermal damage it was completely destroyed. And worse still, the emergency locator transmitter, the ELT, whose sole purpose is to survive a crash and broadcast radio signals to rescue teams, completely failed to activate and was destroyed alongside the rear black box. Which leaves us with one vital, completely unanswered question. Look, this was a catastrophic event, yes, but it was fundamentally a low-speed, low-altitude impact relative to typical aviation disasters. So why did the black box and the ELT, systems literally over-engineered for the singular purpose of surviving a crash, completely fail? As we wrap up this explainer and await the final official report, this haunting question remains, leaving us demanding a much deeper look at the fail-safes and safety systems we all blindly trust every time we take to the skies.